Hello everyone, and welcome to the Complete Python Programming course. In this video, we'll talk about object-oriented programming in Python. This video is part of the beginner tutorial. If you are familiar with the classes in Python and looking for more detailed information, please see my intermediate level tutorials. Classes are a way of grouping data and functionality together. Think of a class as a new type, just like any built-in type, for example, string or integer, but this new type is created by you. Let's take a quick example. L equals empty list and L.append. And we just append 1. Let's run this code. Let's print L and see what that returns. Let's run our program in Python 3 main.py. And it just returned a list. Let's print something else about our list. Let's print type L. And type L returns class list. List is a class. Everything is Python. In Python is an object. Let's see something else about our L, which is a list. Let's see the dir directory L, and it will return a list containing multiple entries. Notice that some of the entries have 2 underscores before and after the name. These are built in, let's say, for now. And there are the other methods that you can use, or methods and attribute as well, attributes, and they are like, for example, the append that we just used is here. Let's see how we can create our own type or our own class. To declare a class in Python, you start with the class keyword and the class name. I will call my class car, followed by colon, and here you define your class. For this class, as a start, let's go with pass. The pass keyword in Python is used to just tell Python that, all right, there will be something here, but for now, let's pass. Like the syntax requires something after the colon, and I don't want to define anything now, so pass is handy. Let me print car and see what that returns. Clear. And run our code, and it's a class car main because we are running it from this terminal because we are running the program as a script. Class car, the same as class list. And notice it doesn't have anything other than that. Let's try to see what we can do with the dir function and see if there is anything in there. And notice that it already has many or some of the methods that we saw in the list. Python took care of that for us. We create a class, and there is the Python way of constructing a class is to create some, let's call them attributes for that class. It looks like a list, but we don't have any methods in our classes or any variables, so this is how it looks. In Python, to do a useful class, to create a useful class, the first thing we need to learn is the init method. To define a function or a method, let's call it a method in a class, we start with the def, like any other function. The first function we'll talk about is init, underscore, underscore, init, underscore, underscore, and followed by parentheses. It's just a method like any other function we talked about, the same as any other function, and colon, and here comes the definition. But there is something we need to add, self. The self keyword here is a reference to the instance itself. We'll talk about that in a while. But for now, each method of the class as the first argument self. In my init method, this is for people coming from other languages. This is the same as constructor for people who are learning this for the first time or are new to programming. This is a function that will be ran for you without you calling it. It will be automatically ran when you run the class. And let's just pass. Now, at this point, we can create an instance of our class, a equals car. This is how you create an instance of your class. Let me print a, and if I print that, it will return car, an object at memory location. We created our instance. Notice that it does nothing at all. Let me try dir at this one just to see what we have. And let's keep actually also this one, print dir a, sorry, car. Notice that I'm not calling the class, I'm calling the class itself, not an instance. So this is just printing whatever that is. Now, I'm printing dir for this and dir for that. Clear? And we should have two dirs. Here is the first one, and here is the second one. Notice that they look very similar. They are actually identical. Like many of these methods are actually coming from the class itself, and it inherited it in a way. My instance, it's an instance of this class. Let's take this one step further and see what we can do with that. In the init method, let's start with print init called. Now, when I create an instance of my class, the init method will be called automatically. Notice that I'm not printing anything here, I'm just creating an instance of my class. And notice that this one has self, I didn't pass anything. Let's see what happens. Run our code, and it says init called. What happens in here, if you are new to programming, once you initialize or instantiate your class, the init method will be called automatically for you. That's the init method. It has a name, and it should always be init with 2 underscores before the word init and 2 underscores after that. If we create multiple instances of our class, you can create as many instances of your class. Think of it the same as you are creating a string. You can create a string a equals a and b equals b. These are classes. You are creating them this way. And I'm just creating my classes because the class I defined is called this way. Now let's run these two, and let's create even a third one, c equal car. Let's run our code and see what happens. And notice that it printed init called 3 times. Every time the class is instantiated, which means that you create an instance of it, the init method is called. Okay. If it's called this way, I can use it if I have something I want to pass to my class. Every car self make equals none. Self year equals none. Let's use the word none here. And self color. Every car has a make and a year and a color for now. Now, if I use these, let's stay with A for now. Let's create an instance of A and see what we can do. And I created an instance and it did absolutely nothing. Now, notice that every variable inside my class, you can call them data members, you can call them variables, you can call them attributes, do whatever you want, call them whatever you want. For me, I prefer to call functions as methods and these as members, data members or variables. Now, how do I pass arguments to my init functions? You just put them here. It's called automatically. These parentheses are for calling this method. So you can just pass them here. You can pass Ford. You can pass 2020, and let's pass black. Now here, this method should take an argument because I am starting and creating an instance with 3 arguments. Let's try to do that now. Let's try to call to create this class. And notice that init takes 1 positional arguments, but 4 were given. It takes 1, I gave it 4. Okay, 2 things to notice about that. It says it takes 1 positional argument, which is clear, self. And 4 were given. I gave 1, 2, 3. Why it is 4? Self is automatically passed for me here. When I create it, the self here is just internal thing in Python. So you don't have to ever pass self to your classes. For now, you never have to pass self for your methods. You call your methods and always self is added automatically for you. So it says I passed 4, although I passed 3. Now, let's take this one step further. Make, year, and color. And set this to make, and this to year, and this to color. Now this will work. It will create an instance and it will just exit. There is no error. Now notice that every data member have the word self before it. Any member of the class should have the word self before it. Self.make. This, if you're coming from different languages, think of these as this. Like all these, it's just like this. And actually, if you run this with this, it will run. The word self is just a convenient way. It's just a convenient, and it was called self from the start. So you can use anything here, but self will make your life easier because this is the way that all the programs are written. Self. Now, to access data in my class, everything in a Python class is all functions, all methods, all variables, or attributes, or data members, call them whatever you want, all of them are public. Notice that there is no way to say this is public and this is a private. There is nothing like that. This will not work in Python. You cannot say public or private here. Now, let's start with accessing variables in our class or data members. That's very simple. Print a.make. Well, I have to learn typing now. Make, year, and color. Now this will run and it will print the 3 values as in my class. Notice that they are public. There is no restriction on accessing them on the instance. How about adding a new data member? You can add it in the class, but there is no problem in doing something like a.doors equals 5, and then accessing that, print a doors. Now this will work, but you really usually don't need to do something like, or you shouldn't do something like that. Variables in the class should be restricted to a class. It's a class. You don't just define them after the class or create variables after you create the class. If you needed the doors, you add the doors some kind in your class at some point. But you can do that in Python. As we are talking about object-oriented, let's talk about a little bit about setters and getters, because these are common way of talking about programming in an object-oriented. To define your methods in the class, you can just use a def keyword and get make. That's a function. One more note that Python, or people usually, and many people do that, they call their methods with underscore between the words. I personally prefer that. It's just my way of doing it. I just don't like having underscores in methods names. Self, notice that the self keyword has to be passed to every method in your class. Self and it has no arguments, and return self make. Notice that I need to access that other data members anywhere using the self. So self make. How about the setter? Def set make and self and an argument just like that value. And self make equals value. That's all about it. Let's try to see how that works. Print a get make and parentheses and a set make. Let's change that to Toyota and a print a get make. For people who are new to programming, I am just getting the make using a function. I'm asking the function to get it for me, get make. Then I am changing the make using this method, which will change the value of make to whatever value I pass. And then I'm getting make again to see that my value changed. Let's run that. And notice that in the first instance, in the first time, it printed Ford, and in the second time it printed Toyota because it was changed by set make. Now that's easy and simple. Let's see what we can do with our classes. We can create other instances. I am not restricted to my A. B equals car, BMW 2019 and red. Let's print a get make and print b get make, and this will work as expected. Now, for people who are new to programming, let's just do something here. When you used to create strings, we used to say a equals hello and b equals world. So what happened in here? When you said a equals hello, you are actually creating a class. You are creating an instance of a class called a string. And here you are creating another instance of the class called a string. Or even when you do these as lists or any other data type, you are creating your instance of that class. This is not at all different. It's just that instead of the class being provided to you by Python, like list or a string or a dictionary or many others, you are writing your own class. And that's about it. Like in list here, when you have a list here and it has, let's say, a value or something like that, just one value. And after that, you come to it and say a append, right? And this is how you add values to your list. And in this case, notice that a.getMake, I am calling a function. It's exactly the same. So it wouldn't be confusing. It's actually a very simple concept. Now, what else we can do? We can create as many of these as possible. And we can, for example, we can put them in our dictionaries, like my cars equals, or let me make it a list. My cars is a list, and you can add A and B. And if you print my cars, it actually works. Here we go. We have the class as a value in our list. And you can even access that. My cars 0 get make. And that will return Ford. It's exactly the same. It can be used as simple as that. Now, you need sometimes multiple data members. You need more data here. If you need variables, or let's call them data members, you don't want to pass to the constructor, you can just create them here. Self, what to do, add for a car, let's say doors. And you can just set it to none. And later you can set it by having a setter or a getter or directly. There is no problem setting your data directly. So here we used get make to get the make of the car. So let's see it in a different way. Print, we tried that, A make, and try B make. It will print exactly what we saw when we did it in the other way. And you can even change them. A make equals Toyota. And if you try that, it will print Toyota, and then after that it will print BMW. Notice that Python is very flexible in the way you access your data members and functions. If you are coming from languages that are more strict than that, especially lower level languages, you will notice that this is very forgiving. Like you can access data members, you can access functions in a very different way and directly. Two things, because this is a beginner tutorial, I would like to keep this restricted to simple things. Two things I would like to mention. Notice that here we added our data members as self, and they are data members or variables. There is another thing you can add to your class, something we call attribute. So attributes, let's call it attribute for now, and it's actually something like data that are shared between all classes. It's not an instance. It's not related to an instance. It is to the class itself. So for example, I will set an attribute here and set its value at, just add 1 here. Now if I try to print this from here, let's print just A and this. Let's see what that print for A and B. For A, for the start, let's start with A, easier. Let's print that and see what it returns. And it returned a list that has the entry 1. Now let's try to change that. Append 2. Now let me print that after that. I want first to append to it. Let's take this, append to it, and this, let's print it. Print it before and after. Let's run our code. And notice that after appending to it, it changed. It has 2, which is something that you might expect it. But let's print B after that and see what happens in here. And notice that the B also changed. Although I called it on the instance, not on the class, it changed. We will talk about that in much deeper details, because this is very tricky topic. But for now, you should know that there is attributes that are shared, as they are attributes of the class, not like these. Like the self ones are for the instance, and these are for the class itself, which is something you don't want to go for as of now. The last thing I would like to mention when it comes to classes is static methods. Sometimes you would see something like this in a classes, static method. And after that, diff, and you have a method name, whatever name that is. I don't have something in mind for this class. And it has return some value. Now notice that when you see static method, you will notice that it doesn't have self keyword. It doesn't have an instance. Static methods are just functions. You just want them to put them inside your class for organizational purposes. So this method would be defined here. And it would look like that. It's just a function. It's not a method, but we call it method because it actually is inside the class. Now, a method usually, or sorry, a function is actually defined by itself. It doesn't belong to a class. Now, when you put a method and you add a decorator to it, this is called decorator. It's add static method. When you add this decorator, you are making the function or the method to become just inside the class because of organizational organizational purpose, not because it belongs to the class. It might be related to a class somehow, but it doesn't need an instance from the class to work. So these methods, you will never see self inside them. And even if you try to access something in there, you will get an error. So if you go here and try something like self make, this method will create an error. So let's run that and see how that goes. So print method name, it's just a function. Let's see, and I would call it on A. Let's see if that would run, and run our code, and it will just create an error. Self is not defined. It doesn't have access to a self because it's not part of your class. We will talk about these in much more details in the future. But for now, just in case if you saw it somewhere and you would like to understand what is a static method, it's just a normal function that you are having inside your class before organizational reasons, not because it belongs to your class. And that's how it works. You just add a decorator at static method. There are other decorators for the classes, and we'll talk about them when we read them slowly. This is about it for today. This is how classes work. It's actually simple. If you are new, please create some classes and try to work with them. Get yourself used to work with the self and with the initializer, the init method, and see how that works for you. It shouldn't be that complex, but if you don't practice, you will never get used to it. If you like this video, support the channel by subscribing. Meanwhile, have a great time.